Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see the principal working of full wave rectifier. In this video we will see the working, characteristics, advantages, disadvantages and applications of full wave rectifier. In previous video we have seen what is rectifier and what are the different types of rectifier, what is the working of half wave rectifier, right? And today we will see about full wave rectifier. And before explaining the working of full wave rectifier, we already know the half wave rectifier, it allows the AC voltage to flow only during positive half cycle, right? That is, in half wave rectifier, rectification will happen in only one half cycle. So that is why it is called as half wave rectifier. But in full wave rectifier, right, we will be using two diodes, right, so that we can able to obtain a pulsating DC in both positive and negative half cycle of AC input. Whereas in half wave rectifier we have used only single diode and it conducts only during one half of the cycle, right? And because of this working of full wave rectifier, the efficiency can be increased, whereas in half wave rectifier the efficiency is around only 40.6, whereas here the efficiency can be increased, can be doubled around 80%. That's because it conducts both during positive and negative half cycle, right? And this full wave rectifier can be constructed using a transformer, and also it can be constructed using a bridge, right? That is, it can be also called as a bridge rectifier. We will see both the working in this particular video, right? And whatever I said before, rectifier is a device which converts an AC voltage into a pulsating DC voltage, whereas in full wave rectifier it converts that into a DC voltage in both the half cycles. And as I said before, you have two different types. One is two diodes full wave rectifier and another one is bridge rectifier. Whereas in two diode full wave rectifier we will use a center tap transformer, whereas in bridge rectifier we will not use central tap transformer. Instead of that we will use four diodes, right? So in two diodes full wave rectifier, this is the circuit of two diode full wave rectifier, where we will be using a center tap transformer. We will be using two diodes, right? And you can see this is the output of this full wave rectifier, which means whenever you give an AC voltage, right, and this center tap transformer, you know the working of center tap transformer, where both the terminals, right, primary and secondary, and the center tap will be grounded, so that whenever you give positive voltage, right, and this diode, the anode of this diode will be positive when compared to this particular diode D2, right? So during positive voltage, D1 will be on and D2 will be off, so that during positive voltage D1 conducts, so that we can obtain this waveform. So it allows this particular voltage to flow through. Conduction will take place. Whereas in the reverse direction, that is in the negative cycle, this becomes negative, it will be turned off, and this becomes positive, right? So conduction will take place, but the conduction now will take place in the negative half cycle, but it will also provide the same waveform. That is because even during a positive half cycle or negative half cycle, the current flows through this RL diode, right? It will be in the same direction, right? And that is why we are representing this voltage, this waveform in same direction, both in positive cycle and negative cycle. Which means here, right, when during the negative half cycle, this diode will become positive and forward biased, whereas this will become negative and this will become reverse biased. And because of this D2, conduction will take place during negative half cycle, and because of D1, conduction will take place during positive half cycle. So you can see here, whatever I said, during positive half cycle, D1 becomes positive. At the same time, the D2 becomes negative. So current conduction will take place, whereas during negative half cycle, the D1 becomes negative and D2 becomes positive. So it allows the voltage to flow through, right? So this is the working of two diode full wave rectifier. And this full wave rectifier can also be constructed using a bridge rectifier, whereas in bridge rectifier we have a simplified circuit when compared to the two diode rectifier construction, whereas we don't need a center tap transformer, right? And the circuit is very small when compared to the other one, right? Whereas here, instead of center tap transformer, we can use a normal transformer and we can use 4 diodes. So the operation is same, that is during positive half cycle, current D1 and D3 becomes forward biased and current conduction will take place, right? It allows the voltage to flow through. And during negative half cycle, the diodes D2 and D4 will become forward biased, whereas D1 and D3 will become reverse biased and voltage will flow through, right? This is the same, the working is same. Instead of using center tap transformer, we are using 4 diodes here, so that 2 diodes will start conducting at positive cycle and 2 different diodes will start conducting at negative half cycle, right? And coming to characteristics of full wave rectifier, again in full wave rectifier I have already explained what is ripple factor. Ripple factor tells you the ripples, the number of ripples that is present in the output voltage, right? When compared to half wave rectifier, full wave rectifier produces a smooth pulsating DC, whereas the ripples is very minimum here because it conducts in both the cycles, right? So it is represented, the ripple factor is represented using this formula gamma, and the DC current is mentioned as 2 I max pi, because here it is mentioned as 2, that's because it conducts in both the cycles. And similar DC voltage is 2 V max pi, whereas in half wave voltage this is I max pi and this is V max of pi, right? And coming to form factor, the form factor of full wave rectifier is 1.11, right? And the rector efficiency, which is the very important parameter for rectifier, the rectifier efficiency, right? The efficiency of a rectifier is increased in full wave rectifier, that is the efficiency is 81.2% compared to half wave rectifier. And coming to advantages and disadvantages, advantages of half wave rectifier, the rectifier efficiency is increased, it is doubled actually, the power loss is very low, the number of ripples is less, right? Whereas the disadvantages is expensive when compared to half wave rectifier. Coming to applications of full wave rectifier, the full wave rectifier is used for supplying polarized voltage in welding and for bridge rectifiers, and also full rectifiers are used for detecting the amplitude of modulated radio signal, right? These are the very important applications of full wave rectifier, whereas for this particular application bridge rectifiers are mostly recommended, right? So today what we have seen is, we have seen the working of full wave rectifier, we have seen the characteristics of full wave rectifier, the advantages and applications of full wave rectifier. I believe this video will be very useful for you. Thank you, my dear students.